On November 12, 2003, geneticist Dr. Carla Puffenberger received an overnight FedEx package at her clinic in Strasburg, Pennsylvania. Inside were 3 small vials of blood drawn from Hutterite children in rural Manitoba. Children who couldn't walk, couldn't speak, and were slowly losing their sight. The accompanying medical notes described symptoms that made Dr. Puffenberger's breath catch in her throat: severe developmental delays, failure to thrive, and progressive neurological deterioration. When the genetic analysis came back weeks later, all 3 children tested positive for Bowen-Conradi syndrome, a genetic condition so extraordinarily rare it had only been documented in medical literature 18 times worldwide. The syndrome affects fewer than 1 in 10 million births globally. Finding 3 cases in the general population would be statistically impossible. But these weren't random cases from the general population. These 3 children all lived in a single Hutterite colony of just 89 people in Manitoba. Over the next 18 months, Dr. Puffenberger would identify 12 cases of Bowen-Conradi syndrome in that single colony. 12 cases of a condition that medical textbooks classified as extremely rare. The statistical probability of this occurrence in a random population approached 0. What Dr. Puffenberger had discovered wasn't just a medical anomaly. It was evidence that 500 years of religious isolation had created living genetic laboratories scattered across the Canadian prairies. The Hutterites hadn't just preserved their 16th century Anabaptist faith through centuries of persecution and migration. They had accidentally preserved 16th century European genes, concentrating rare genetic conditions at rates that stunned the international medical community. Their commitment to religious isolation had created what geneticists would later recognize as one of the most genetically homogeneous populations on Earth, a community where devastating genetic conditions emerged from the gene pool like archaeological artifacts surfacing from the prairie soil. What happened in these peaceful farming communities reveals how religious devotion can become genetic destiny, how faith-based isolation can preserve both cultural traditions and deadly mutations, and why these humble agricultural colonies became crucial to unlocking some of medicine's greatest mysteries. But before we delve into the genetics, we need to understand how 500 years of history created this extraordinary biological phenomenon. Let us know in the comments where you're watching from, and stay with me until the end, because a Hutterite story proves that sometimes the most profound scientific discoveries emerge from the most unexpected places. Drive west across the windswept prairies of Saskatchewan on Highway 7, past endless wheat fields rippling like golden oceans and oil derricks pumping steadily against a vast sky, and you'll encounter something that seems transported from another century. Every 10 to 15 miles, tucked behind carefully planted groves of sheltering trees, sit clusters of identical white buildings arranged in perfect geometric patterns around central courtyards. These are Hutterite colonies, 168 of them scattered across Alberta, Saskatchewan, and Manitoba, with another 40 dotted in the northern plains of Montana and the Dakotas. Each colony houses between 80 and 150 people living in complete economic and social isolation from the outside world. By design, no colony sits closer than 10 miles to the nearest town. This geographic separation isn't accidental. It's theological necessity rooted in 5 centuries of persecution, migration, and unwavering faith. The story begins in 1528 in the mountains of Austria, where a charismatic preacher named Jacob Hutter gathered followers around a radical interpretation of Christianity. Hutter's Anabaptists rejected infant baptism, refused military service, and most controversially, practiced complete communalism, sharing all property, resources, and labor. In an era when church and state were inseparable, these beliefs were revolutionary and dangerous. Hutter himself was captured and burned alive in 1536, but his followers, now called Hutterites, survived by fleeing deeper into the European wilderness. For 240 years, small bands of Hutterites moved constantly across Central Europe, seeking refuge from Catholic armies, Protestant reformers, and secular authorities who viewed their communal lifestyle as subversive. By 1770, fewer than 800 Hutterites remained alive. Facing extinction, they accepted an extraordinary invitation from Catherine the Great of Russia, who promised religious freedom and exemption from military service in exchange for agricultural expertise in colonizing the Ukrainian steppes. In Russia, something remarkable happened. For the first time in their history, the Hutterites found safety and prosperity. Their population exploded from 800 to over 1,200 within a generation. They established thriving agricultural communities and developed sophisticated farming techniques that made their colonies models of rural productivity. But this golden age carried a hidden genetic cost that wouldn't become apparent for another century. During their Ukrainian period, the Hutterite gene pool underwent what geneticists now recognize as a severe founder effect. The entire modern Hutterite population, all 50,000 individuals across North America, descends from just 89 people who survived European persecutions and migrated to Russia. These 89 founders carried within their DNA all the genetic material that would be available to future generations. Whatever beneficial genes they possessed would be preserved and amplified. Whatever harmful mutations they carried would also be preserved and amplified. The Russian period ended abruptly in 1871 when Tsar Alexander II revoked their military exemption and began forcing Hutterite young men into the imperial army. Faced with choice between military service and abandoning their homeland, virtually the entire Hutterite population chose exile. Between 1874 and 1879, over 1,000 Hutterites sold their prosperous Russian farms and migrated to the American Great Plains, settling in South Dakota and Montana. But even in America, their isolation continued. The Hutterites spoke German in an English-speaking nation. They practiced communalism in a culture that celebrated individual property rights. They maintained 16th century dress and customs in a rapidly modernizing world. Most importantly for our story, they maintained strict religious endogamy. Marriage only within the Hutterite community was permitted. No genetic material entered their gene pool from the outside world. World War I brought new persecution. Anti-German hysteria led to mob violence against Hutterite colonies. Several young Hutterite men were imprisoned as conscientious objectors and died in military custody under suspicious circumstances. In 1918, facing systematic harassment, nearly all Hutterite colonies abandoned the United States and moved north to Canada, where the government offered guarantees of religious freedom and military exemption. This final migration created the geographic foundation for the genetic phenomenon Dr. Puffenberger would discover 85 years later. The Canadian Hutterites established their colonies in the most isolated regions of the prairie provinces, ensuring maximum separation from the outside world. They organized into three distinct groups, the Schmiedelut, Dariuslut, and Laralut, each maintaining separate leadership structures and genealogical records stretching back to their 18th century Russian ancestors. The first hints that something was genetically unusual about the Hutterites emerged in the early 1990s, buried in routine pediatric reports at rural Canadian hospitals. Dr. Susan Berry, a pediatric neurologist at the University of Calgary, began noticing an unusual pattern in her patient files. Hutterite families were bringing children to her clinic with rare metabolic disorders at rates that seemed to defy medical probability. At first, Dr. Berry dismissed these cases as coincidental clustering, the kind of statistical anomaly that occasionally appears in small populations. Medical literature is filled with examples of rare diseases appearing in unexpected concentrations due to pure chance. But as the 1990s progressed, the pattern became impossible to ignore. Hutterite children were presenting with Leigh disease, a devastating neurological condition that destroys the brain's energy production systems. They were developing Pearson syndrome, a bone marrow disorder that causes metabolic acidosis and early death. They were suffering from Hirschsprung disease, a condition where portions of the intestine lack the nerve cells necessary for normal function. Each of these conditions occurs in fewer than 1 in 50,000 births in the general population. Yet Dr. Berry was seeing multiple cases each year, all from a population of fewer than 30,000 Canadian Hutterites. The statistical probability of this occurrence approached mathematical impossibility. The breakthrough came in 1996 when Dr. Laura Arbour, a medical geneticist at the University of British Columbia, received a grant to investigate genetic disorders in isolated Canadian populations. Dr. Arbour had studied genetic conditions among the Inuit of northern Canada and suspected that other isolated communities might harbor similar concentrations of rare genetic disorders. When Dr. Arbour first approached Hutterite colony leadership about genetic research, she encountered deep suspicion and resistance. The Hutterites had spent 5 centuries protecting their communities from outside interference. Their religious doctrine emphasized acceptance of God's will, and many colony members viewed genetic testing as attempting to interfere with divine providence. There were also practical concerns about stigmatization and discrimination if their genetic conditions became widely known. However, some Hutterite families have been keeping their own records of what they called family conditions, developmental delays, seizure disorders, and early deaths that seem to run in particular family lines across multiple generations. These families, desperate for answers about their children's suffering, became Dr. Arbour's first research partners. In 1998, the University of British Columbia formally established the Hutterite Genetic Research Program with Dr. Arbour as its director. The initial research focused on collecting detailed family histories and mapping genealogical relationships within and between colonies. What they discovered was unprecedented in population genetics research. The investigation revealed that modern Hutterite genealogical records, meticulously maintained by colony leadership since the 18th century, could trace virtually every living Hutterite back to specific founders from the Russian period. These records show that the average coefficient consanguinity, a measured genetic relatedness, among Hutterites was 0.034, approximately equivalent to marriages between first cousins once removed. In comparison, the consanguinity coefficient in the general North American population is less than 0.001. By 2000, Dr. Arbour's team had completed the first comprehensive genetic mapping of Hutterite bloodlines and discovered something that stunned the international genetics community. Specific genetic conditions were clustering not randomly across the Hutterite population, but along predictable family lineages that could be traced back to individual 18th century founders. Bowen-Conradi syndrome, the condition that would later capture Dr. Puffenberger's attention, was concentrated almost exclusively in colonies descended from a single founding family. Lee disease appeared primarily in Dariuslet colonies, while Pearson syndrome was most common among the Schmiedelit. The genetic legacy of 89 18th century individuals was still expressing itself in their 21st century descendants, like DNA time capsules preserved across 8 generations of isolation. But resistance to genetic testing remained strong in many colonies. Traditional Hutterite midwives had developed their own explanations for the developmental disabilities they encountered. Some viewed these conditions as tests of faith or divine punishment for community sins. Others simply accepted them as normal variations in human development, since they had been present in Hutterite families for as long as anyone could remember. The discovery that would change everything came in 2003 when colony records from rural Manitoba identified 3 children with identical symptoms: severe developmental delays, failure to thrive, and progressive neurological deterioration. The colony's designated medical liaison, following Dr. Arbour's research protocols, arranged for blood samples to be sent to Dr. Puffenberger's specialized genetics laboratory in Pennsylvania. When Dr. Puffenberger genetic analysis confirmed that all 3 Manitoba children carried identical mutations causing Bowen-Conradi syndrome, she immediately recognized the profound implications. This wasn't simply a case of rare disease clustering. It was evidence of one of the most extreme examples of genetic isolation in modern human populations. The investigation that followed would span the next decade and involve geneticists, anthropologists, historians, and medical specialists from institutions across North America and Europe. What they uncovered was a genetic time capsule that preserved not just rare diseases, but an unprecedented window into human evolutionary biology. The historical deep dive revealed the precise mechanisms through which 500 years of religious isolation had created this genetic phenomenon. Between 1528 and 1770, the original Hutterite population had been reduced through persecution, warfare, and disease from thousands to fewer than 800 individuals. This dramatic population bottleneck eliminated vast amounts of genetic diversity from their gene pool, a process geneticists term genetic drift. During their 100-year residence in Russian Ukraine from 1770 to 1874, The surviving Hutterites experienced rapid population growth, expanding from 800 to over 1,200 individuals. However, this growth occurred entirely through internal reproduction within the closed community. No genetic material entered from the surrounding Ukrainian peasant population. The founder effect, already severe from the European persecutions, became even more concentrated. Medical documentation began revealing the full scope of genetic conditions preserved within this isolated gene pool. Dr. Arber's team, working with colony genealogical records dating to the 1700s, constructed the most comprehensive genetic database of any human population in history. Over 15,000 Hutterites across Canada and the northern United States provided DNA samples, creating what became known as the Hutterite Genome Project. The mutation analysis revealed over 150 disease-causing genetic variants circulated within the Hutterite population, many of them lethal recessive mutations that would be extremely rare in outbred populations. The mathematics of genetic inheritance in small, isolated populations meant that these harmful mutations were being expressed at extraordinary rates. Bowen-Conradi syndrome, caused by mutations in the EMG1 gene, occurred in 1 in 355 Hutterite births, nearly 30,000 times more frequently than in the general population. Lee disease, resulting from mutations in multiple genes affecting cellular energy production, appeared in 1 in 1,700 Hutterite births, compared to 1 in 77,000 births globally. Pearson syndrome struck 1 in 2,000 Hutterite children versus 1 in 1 million in the outside world. But the genetic investigation revealed something even more remarkable. The specific pattern of genetic conditions could be mapped directly onto the 3 main Hutterite subdivisions, the Schmiedelut, Dariuslut, and Laralut, which had maintained separate breeding populations since their migration to Russia in the 1770s. Each group carried distinct sets of founder mutations, creating what geneticists recognized as 3 separate genetic subpopulations within the broader Hutterite community. Dr. Laura Arber's research team discovered that the average Hutterite individual carried genetic variants equivalent to a coefficient of inbreeding of 0.034, meaning that genetically, the average Hutterite marriage was equivalent to a union between first cousins once removed. In comparison, the coefficient of inbreeding in the general North American population is less than 0.001. The living conditions within Hutterite colonies had preserved not only genetic isolation, but also detailed genealogical records that made this research possible. Each colony maintained meticulous family trees recorded in ornate German script, tracking marriages, births, and deaths across 8 generations. These records, combined with the community's cultural prohibition against marriage outside the faith, created an unparalleled genetic time series. Colony life itself reinforced the genetic isolation. Hutterite communities practice complete economic communalism, with all property owned collectively and work assignments determined by colony leadership. Children attended school only through 8th grade, receiving education focused on practical agricultural skills and religious instruction. Social contact with the outside world was minimal and carefully controlled. The agricultural focus of colony life had created some of the most productive farming operations in North America, with Hutterite colonies generating disproportionate amounts of livestock, grain, and dairy products. However, this economic success masked the growing genetic crisis affecting their children. Colony leaders had developed cultural explanations for the developmental disabilities appearing in their communities, viewing them as tests of faith or divine will rather than preventable genetic conditions. Dr. Carla Puffenberger's analysis of the Hutterite genetic database revealed patterns that challenged fundamental assumptions about human genetic diversity. The Hutterites represented what she termed a living laboratory of human genetics, a population where rare genetic variants could be studied in concentrations impossible to achieve in outbred populations. Genetic counselor Mary Brough, who began working with Hutterite families in 2004, documented the profound impact of genetic education on colony attitudes toward inherited diseases. Many families have been carrying guilt and shame about their children's conditions for generations, believing they had somehow caused these disabilities through moral failings or insufficient faith. The medical analysis revealed that collectively, genetic disorders affected approximately 8% of the total Hutterite population, a rate nearly 100 times higher than observed in the general population. However, The specific conditions vary dramatically between colony lineages, creating distinct genetic signatures that could be traced back to individual 18th century founders. The transformation from genetic discovery to medical intervention began in 2001 when Health Canada launched the Hutterite Genetic Health Initiative, recognizing that this isolated population faced a public health crisis requiring unprecedented government response. Unlike typical genetic diseases that affect scattered individuals across large populations, the concentration of rare genetic conditions within Hutterite colonies created an opportunity for targeted medical intervention that could serve as a model for treating genetic diseases globally. Dr. Brenda Galley, Ontario's Chief of Medical Genetics, led the federal response team that developed protocols specifically for working with isolated religious communities. The challenge was enormous. How do you provide modern genetic medicine to a population that had historically viewed outside medical intervention with deep suspicion and whose religious beliefs emphasize acceptance of divine will over medical intervention? The breakthrough came through careful collaboration with Hutterite religious leadership. Colony elders, faced with mounting evidence about the preventable nature of their children's suffering, began engaging with the medical research community in ways that had been unthinkable just decades earlier. The turning point occurred during a 2002 meeting between federal health officials and the Council of Hutterite Elders, where genetic counselor Mary Brock presented data showing that genetic testing could prevent up to 80% of severe genetic conditions without violating any core religious principles. Elder Joseph Kleinsasser of the Darius Colonies, whose own grandson had died from Lee disease, became one of the first religious leaders to publicly endorse genetic screening programs. Our faith teaches us to care for the vulnerable and to use the gifts God provides, Elder Kleinsasser stated in a 2003 interview with the Canadian Medical Association Journal. If medical knowledge can prevent our children from suffering, then refusing that knowledge becomes a sin against the children themselves. By 2005, the Alberta Ministry of Health had allocated $2.3 million in specialized funding for Hutterite Genetic Health Services, establishing mobile genetic clinics that travel between colonies on rotating schedules. These clinics provided genetic screening, counseling, and treatment coordination while respecting Hutterite customs and religious sensitivities. The University of Manitoba established the Hutterite Research Center in 2008 with Dr. Cheryl Rockman Greenberg as its director, creating the first academic institution dedicated specifically to genetic medicine in isolated populations. The center developed protocols that became international models for providing genetic services to close religious communities while maintaining cultural sensitivity and community autonomy. The medical intervention programs began with voluntary genetic screening for all community members, starting with carrier testing for the most common recessive conditions. Unlike mandatory public health programs, the Hutterite Genetic Services operated on principles of informed consent and community self-determination. Families could choose which tests to receive and how to use the genetic information, with genetic counselors providing education and support rather than directive medical advice. Prenatal diagnosis emerged as one of the most controversial aspects of the intervention program. Traditional Hutterite theology emphasized acceptance of pregnancy outcomes as divine will, making prenatal genetic testing philosophically challenging for many families. However, genetic counselor Mary Brock worked with colony midwives and elders to develop culturally appropriate approaches to genetic information that respected religious beliefs while providing medical options. The first major breakthrough came in 2007 when Dr. Puffenberger's laboratory successfully treated a Hutterite infant with Bowen-Conradi syndrome using experimental gene therapy techniques. The treatment, delivered through modified viral vectors that corrected the defective EMG1 gene, represented the first successful genetic cure for a Hutterite-specific condition. The infant, previously expected to die within 2 years, showed normal development at age 5. By 2009, comprehensive genetic counseling programs had reduced the incidence of severe genetic conditions in participating colonies by 40%. Families were using genetic information to make informed decisions about marriage partnerships, family planning, and medical care without abandoning their religious convictions or communal lifestyle. The stem cell therapy trials that began in 2012 marked another milestone in Hutterite genetic medicine. Dr. Arbor's research team, working with international collaborators, developed treatments using umbilical cord stem cells to treat metabolic disorders common in Hutterite children. The trials, conducted with full community consent and religious approval, showed remarkable success in treating conditions previously considered uniformly fatal. In 2015, Health Canada approved the first CRISPR gene editing research protocols specifically designed for Hutterite genetic conditions. The approval came after extensive consultation with Hutterite religious authorities, bioethics committees, and the communities themselves. Colony elder Peter Waldner, whose family had been devastated by genetic disease, spoke at the approval hearing. Our ancestors preserved our faith through 5 centuries of persecution. Now we must preserve our children through the gifts of modern medicine. The community collaboration that emerged from these medical interventions transformed Hutterite society in ways that extended far beyond healthcare. Elder councils began incorporating genetic education into religious instruction, teaching young people about inheritance patterns alongside traditional theology. Marriage customs evolved to include voluntary genetic counseling, allowing couples to make informed decisions about family planning while maintaining religious autonomy. Educational programs developed specifically for Hutterite communities integrated genetic literacy into the limited formal education provided in colony schools. Children learned about DNA inheritance using examples from their own family trees, making complex scientific concepts accessible within their cultural context. Medical partnerships between colonies and specialty hospitals created new models for delivering genetic services to isolated populations. The Alberta Children's Hospital established a dedicated Hutterite genetic clinic, while the University of Saskatchewan developed telemedicine programs that allowed genetic specialists to consult with colony families without requiring travel to urban medical centers. The transformation of Hutterite genetic health services from experimental intervention to integrated medical care represents one of the most successful examples of precision medicine applied to an isolated population. By 2010, what began as Dr. Puffenberger's investigation of 3 blood samples had evolved into a comprehensive genetic medicine program serving over 50,000 Hutterites across North America. The establishment of specialized Hutterite genetic medicine centers marked a fundamental shift in how rare genetic diseases could be treated when concentrated in specific populations. The Clinic for Special Children in Pennsylvania, originally founded by Dr. Puffenberger to serve Amish and Mennonite communities, expanded its mission to include comprehensive Hutterite genetic services. The clinic developed treatment protocols that could be adapted for other isolated populations worldwide. Gene therapy emerged as the most revolutionary aspect of Hutterite genetic medicine. Dr. Puffenberger's successful treatment of Bowen-Conradi syndrome using modified viral vectors opened pathways for treating multiple genetic conditions that had previously been considered incurable. By 2015, gene therapy protocols were being used to treat Hutterite children with Lee disease, Pearson syndrome, and several metabolic disorders with success rates exceeding 70%. The preventive care programs developed for Hutterite communities became models for population-based genetic medicine. Early intervention programs identified genetic conditions in newborns before symptoms appeared, allowing treatments to begin during critical developmental windows. Newborn screening protocols developed specifically for Hutterite populations were later adapted for use in other communities with high rates of genetic disease. Family support services evolved to address the complex cultural and religious dimensions of genetic disease within Hutterite communities. Genetic counselors worked closely with colony midwives, elders, and traditional healers to develop holistic approaches to genetic medicine that honored both scientific knowledge and religious faith. These programs demonstrated that genetic medicine could be integrated into traditional communities without undermining cultural values or religious beliefs. The broader medical impact of Hutterite genetic research extended far beyond the colonies themselves. The concentration of rare genetic conditions within this population allowed researchers to study diseases that were virtually impossible to investigate in the general population. Drug development programs use Hutterite genetic data to develop treatments for rare metabolic disorders, neurological conditions, and developmental disabilities that affect children worldwide. Research outcomes from the Hutterite Genome Project contributed to the identification of 47 previously unknown disease genes, advancing understanding of human genetic diversity and disease mechanisms. These discoveries led to improved diagnostic tools, new therapeutic targets, and enhanced genetic counseling protocols that benefit patients globally, not just within Hutterite communities. The development of new therapeutic compounds based on Hutterite genetic research accelerated treatment options for rare diseases worldwide. 12 new drugs entered clinical trials between 2010 and 2020, specifically designed to treat genetic conditions that were first studied intensively in Hutterite populations. These medications now serve patients with rare genetic diseases regardless of their ethnic or religious background. Community adaptation within Hutterite colonies reflected remarkable flexibility in integrating modern genetic medicine with traditional religious practice. Colony leadership developed new theological frameworks that viewed genetic medicine as consistent with their core religious obligation to protect and nurture children. Elder councils began incorporating genetic education into religious instruction, teaching that understanding genetic inheritance was a form of stewardship over the gifts God had provided. Marriage practices within Hutterite communities evolved to include voluntary genetic counseling as a standard component of courtship and engagement processes. Young couples could receive genetic compatibility testing that identified potential risks for genetic disease in their children without violating religious principles regarding arranged marriages or community approval unions. These programs reduced the incidence of severe genetic conditions by 60% while maintaining traditional marriage customs and community autonomy. Healthcare access improvements transformed medical care delivery to isolated rural populations. The mobile genetic clinics developed for Hutterite colonies became templates for serving other remote communities across Canada's prairie provinces. Telemedicine programs allowed genetic specialists to provide consultation services to families who previously had no access to specialized medical care. Support networks developed between Hutterite colonies created unprecedented levels of intercommunity cooperation around health issues. Colonies began sharing resources, medical expertise, and genetic information in ways that strengthened both individual communities and the broader Hutterite population. These networks facilitated rapid dissemination of new treatments and genetic information across the widely scattered colony system. The autism genetics research that emerged from Hutterite studies identified several new autism risk genes and advanced understanding of the genetic factors contributing to autism spectrum disorders. The University of British Columbia's Hutterite Autism Research Program, established in 2016, became one of the leading centers for autism genetics research globally, with findings that benefit children worldwide. Metabolic medicine breakthroughs achieved through Hutterite research led to improved treatments for rare metabolic conditions affecting energy production at the cellular level. The development of new enzyme replacement therapies, dietary interventions, and pharmaceutical treatments has extended life expectancy and improved quality of life for children with metabolic disorders both within and outside Hutterite communities. Neurological research conducted with Hutterite populations advanced understanding of inherited brain disorders, leading to new treatments for conditions affecting motor function, cognitive development, and sensory processing. The concentration of neurological genetic conditions within Hutterite populations allowed researchers to study disease progression and treatment response in ways impossible with scattered individual cases. Cancer genetics discoveries emerging from Hutterite research identified novel tumor suppressor genes and enhanced understanding of hereditary cancer syndromes. While cancer rates in Hutterite populations are generally lower than in the general population due to lifestyle factors, the genetic homogeneity of the population allowed researchers to identify cancer susceptibility genes with unprecedented precision. 20 years after Dr. Carla Puffenberger first analyzed those 3 blood samples from Manitoba, the Hutterite Genetic Medicine Program stands as one of the most remarkable success stories in the history of precision medicine. What began as a medical mystery has evolved into a comprehensive model for treating genetic diseases in isolated populations while preserving cultural identity and religious autonomy. The long-term impact extends far beyond the prairie colonies where the story began. The Hutterite Genetic Medicine Institute, established in 2018 as a joint initiative between Canadian and American research institutions, serves as a permanent center for studying genetic diseases in isolated populations. The Institute's research protocols and treatment approaches have been adapted for use with other genetically isolated communities worldwide, from the Amish of Pennsylvania to the Faroe Islands of the North Atlantic. International collaboration networks stemming from Hutterite research now connect genetic medicine centers across 6 continents, sharing treatment protocols, research methodologies, and therapeutic innovations developed through work with isolated populations. The Hutterite research model has become the gold standard for conducting genetic research in closed religious communities while maintaining ethical standards and cultural sensitivity. Medical training programs established at major universities now include specialty fellowships in population genetics and isolated community medicine, with many fellows completing rotations in Hutterite Genetic Medicine Centers. These programs are training a new generation of genetic medicine specialists equipped to work with culturally distinct populations while respecting religious beliefs and community autonomy. The community health model developed for Hutterite populations has been implemented in indigenous communities across northern Canada, remote Pacific Islands, and isolated mountain communities in Asia and South America. The success of integrating modern genetic medicine with traditional cultural practices has inspired similar programs worldwide, demonstrating that precision medicine can be adapted to respect diverse cultural contexts. Dr. Laura Arbour, reflecting on 25 years of Hutterite genetic research in a 2024 interview, emphasized the transformative nature of the collaboration. When we began this work, we thought we were simply studying rare genetic diseases in an unusual population. What we discovered was that genetic isolation, which seemed like a medical disadvantage, actually created unprecedented opportunities for understanding human biology and developing treatments that benefit everyone. The Hutterites didn't just participate in research, they became partners in advancing genetic medicine for the entire world. Colony elder Peter Waldner, now 89 years old and grandfathered 12 healthy great-grandchildren, reflected on the transformation he witnessed within his own community. When I was young, we accepted that some children would be born with conditions that would cause them to suffer and die early. We thought this was God's will, and questioning it showed lack of faith. Now we understand that God gave us minds capable of learning about genetics and hands capable of healing. Using genetic medicine to protect our children isn't abandoning our faith. It's the highest expression of our faith's command to care for the vulnerable. The policy changes initiated by Hutterite genetic medicine research have had lasting impact on genetic healthcare delivery across North America. The Canadian Genetic Privacy Act of 2019 incorporated protections for genetic information that were first developed to address the unique needs of Hutterite communities. The rare disease strategy implemented by Health Canada established national funding mechanisms for orphan genetic conditions based on the successful model of Hutterite genetic health services. Community health programs designed for isolated populations have been expanded to serve rural communities across the prairie provinces, bringing specialized genetic services to farmers, ranchers, and small towns that previously had no access to genetic medicine. The telemedicine protocols developed for Hutterite colonies now serve thousands of families in remote areas who can receive genetic counseling and specialized care without traveling to urban medical centers. Research ethics guidelines established through work with Hutterite communities have influenced international standards for conducting genetic research with vulnerable populations. The protocols developed for obtaining community consent, protecting genetic privacy, and sharing research benefits have been adopted by research institutions worldwide and incorporated into international human research ethics frameworks. The broader implications of Hutterite genetic research continue to shape understanding of human evolution, population genetics, and disease susceptibility. The Hutterite population represents one of the most thoroughly studied human populations in history, with genetic, medical, and social data spanning over 2 decades. This comprehensive database continues to yield new insights into relationships between genetic diversity, population structure, and health outcomes. Founder effect understanding has been revolutionized through Hutterite studies, providing the clearest example of how genetic isolation affects human populations over multiple generations. These findings have implications for understanding genetic diversity in all human populations, from large urban centers to small isolated communities, and inform strategies for maintaining genetic health in an increasingly connected world. The precision medicine revolution has been accelerated by discoveries made through Hutterite genetic research. The ability to study genetic diseases in concentrated populations has led to faster drug development, more accurate diagnostic tools, and more effective treatment protocols that benefit patients worldwide. Many of today's most advanced genetic therapies trace their development back to research first conducted with Hutterite families. Population health lessons learned from Hutterite communities inform public health strategies for managing genetic diversity and preventing genetic diseases in populations of all sizes. The success of genetic counseling programs, community education initiatives, and preventive medicine approaches developed for Hutterite colonies provides templates for improving population health globally. Dr. Cheryl Rockman Greenberg, current director of the Hutterite Research Center at the University of Manitoba, summarized the lasting significance of this research in her 2023 annual report. The Hutterite Genetic Medicine Program proved that genetic destiny is not inevitable. With knowledge, compassion, and respect for cultural values, we can change health outcomes while preserving what communities value most. The Hutterites showed us that the future of medicine lies not in choosing between tradition and innovation, but in finding ways to honor both. The final call to vigilance emerges from this remarkable story of transformation. The Hutterite colony's genetic journey evolved from isolation into collaboration, from genetic destiny into genetic opportunity. Their 500-year experiment in communal living accidentally created one of medicine's most valuable research populations. But their true legacy lies in proving that genetic knowledge and religious faith can work together to protect the most vulnerable members of our communities. As we advance into an era of unprecedented genetic technologies and personalized medicine, the lesson of the Hutterite colonies remains clear. Genetic isolation can preserve culture, but genetic knowledge preserves lives. The peaceful farming communities of Canadian prairies became laboratories for the future of human genetic medicine, demonstrating that sometimes the most profound scientific advances emerge in the most unexpected places.